Webinar series for Pinelands Preservation Alliance. We've been keeping the Pinelands green for 35 years. Although I've only been there for about 3 of those years. I've been the policy director at PPA since 2022. And I'm excited today to talk about climate change with all of you. And we're gonna integrate some geology into there. So to celebrate that, I've put a picture of myself on a spring break geology field trip from college about a decade ago. So today's agenda, we're going to be talking about how South Jersey, how its geology and climate have interacted to create the South Jersey that we know today. We'll go over some of the basics of climate change, and then we'll talk about some of the early signs of change in the Pinelands that we've been seeing. And my colleague Jennifer Crummins will jump in to help with that. And then finally, we'll talk about future projections of what climate change means for us. And we'll have a couple of breaks along the way to take your questions. So go ahead and put them in the Q&A box that we can address when we get there. So we're all together here online on this very sweltering day in June. I loved this post from Nor'easter Nick the other day. He said, "Think today was bad, here's tomorrow's forecast." And we can see South Jersey here is like right next to the sun. So of course, the Earth has experienced ups and downs in its temperature. The spike that we're experiencing right now is weather, but this also interacts with climate that describes how weather performs over the long term. So on this graph here, we can see on the x-axis how time is progressing as we move from left to right. And then on the y-axis, you can see how the temperature of the Earth has gone up and down over time. So I'm going to use this little image here to move us through geological time. And we're going to look at some of the early phases of what New Jersey would have looked like millions of years ago. And we've got this nice little summary bar on top that shows generally how cool or warm was the climate during these periods of time. So we're going to start in the Carboniferous period, which is very significant when we're talking about climate change. This is when most of the fossil fuels were formed. You had coal formation occurring because plants were dying in swamps. They were buried under layers of water and dirt, and then heat and pressure formed these dead plants into coal. And then you would also have petroleum and natural gas formation. This is when animals would die and were buried under layers of the ocean floor. And these layers were buried deeper, and heat and pressure turned them into the petroleum and natural gas that we take out of the earth today. Jumping forward to the Jurassic period, during this time, what we would know today as New Jersey was right in the middle of this megacontinent Pangea, which started to break up about 200 million years ago. And so where that breakup happened, you had the mid-ocean ridge that started to expand, and it would have pushed New Jersey outwards like this. So we were taking this conveyor belt ride out away from the edge of the mid-ocean ridge. And moving forward to the Cretaceous period, South Jersey was a hotbed of dino action. Love this little gift shop item that you can get at the Edelman Fossil Park. So during this time, New Jersey the world was warm and wet, and the sea levels were very high. So during the Cretaceous and Tertiary periods, the coastal plains, like South Jersey, they were repeatedly submerged in the ocean. And you can go visit the Edelman Fossil Park that recently opened in South Jersey, where you can dig up fossils that show you evidence of the first the dinosaurs, the extinction events, and the repeated submergences of South Jersey during that time. It's a really cool place. To highly recommend it. So when this Cretaceous period came to the end, there was the very famous extinction event, which wiped out the dinosaurs. So when you think of an extinction event, the dinosaurs are probably what comes to mind for you. And I think that the leading theory at this moment is that it is the impact of a meteor that caused this. There's been some debate of like, was it volcano activity, etc. There were some climate changes that followed this, but the main thing that kicked it off was this impact. Moving forward to the Paleocene and Eocene thermal maximum, that was actually another extinction event that's less well known, but it is the closest analog that we have to climate change today. So this extinction event was caused by global warming, and that was known to be a 5 degrees Celsius increase over the course of 5,000 years. So over those 5,000 years, you had a relatively slow uptick in temperature, but that was enough to wipe out many species. Then moving forward to the Miocene, that's when we start to get the New Jersey that we know of today. So you can see that South Jersey is yellow in this figure. It's the coastal plain. It's got very different geology from the rest of New Jersey. And that's because during this period of time, the ocean was moving back and forth, laying down layers of sediment, and that's what's formed the Kirkwood-Cohansey aquifer of today. So if we take a slice of South Jersey and we look underneath the surface, we can see all these layers of different sediments that impact the way that water flows throughout South Jersey. And I like to compare it to a layer cake. So first, the metamorphic rock that was under New Jersey for most of its geologic history. I think of that as the cake stand. And then during this Miocene era, when you had the ocean laying down layers of sediment, and there were also rivers, and just as the ocean, as the coast moved back and forth, that impacted what kind of sediments were being laid down. So then that formed the Kirkwood unit. And within that, you have what I would compare to cake layers. Those are the sandy layers where the water gets trapped and can move in between these pore spaces. And layered in between those, you have what I compare to the ganache layers. Those are made of silt and clay, and they make it more difficult for the water to move in between. So there is water that moves throughout here, but it moves most easily throughout the cake layers. And then on top, you have the Cohansey unit. So that's sand that's even more coarse than the sand that was below. So although in this picture it's frosting, it's probably more like a coconut topping. It's got even larger pore spaces, and it's much easier for the water to flow through there. And depending on where you are in South Jersey, it can be anywhere between 200 and 300 feet deep. And that was laid down about 12 million years ago. Okay, so a quick plug for the Kirkwood-Cohansey Aquifer, which is at the center of much of our advocacy at Pinelands Preservation Alliance. So although I described it as these neat layers, when you actually dig down into the surface, it's a little messier than that. And that's because of that movement that we had of the ocean moving back and forth over New Jersey. And so in many areas, you can see these cross-bedded layers of rock that are evidence that a barrier island was once right in the middle of New Jersey or wherever you are digging. So where we know our barrier islands today, that is not where they have been in geologic history for the whole time. And since South Jersey is mostly these layers of sand, it doesn't have much topographic relief. The highest point is Apple Pie Hill, which is about 209 feet. Not sure if that is counting the fire tower or not. I had some colleagues who went to go up on that the other week. DEP opens it up sporadically. So apparently it's a great experience that we would highly recommend, but it's not for those who are afraid of heights. So during the Miocene, our beloved Kirkwood-Cohansey Aquifer was formed. And then that was followed by the Pliocene epoch, which had high sea levels. You can see on this figure here that all of New Jersey, all of South Jersey would have been submerged in ocean during this time. And then that was followed by the Pleistocene epoch, which was characterized by glaciers. So 20,000 years ago, that line that is just above South Jersey, that is how far south the glaciers had come during that time. And then that was also paired with a coastline that was further out. So the Jersey Shore as we would have known it at the time, was actually 80 to 90 miles east of what we currently know as the Jersey Shore. And so the glacier got off the turnpike at exit 10 and didn't actually come into South Jersey, but we were still impacted by the presence of this very large ice mass. So we would describe South Jersey as periglacial for that reason. So it was characterized by having permafrost and seasonal freezing and thawing. And then the winds that were coming off of these glaciers, the katabatic winds, they pushed that sand around that had been formed by the ocean and created sand dunes that we can still find evidence of today. And highly recommend a podcast that we did with Mark Dimitrov, where he describes much more of this periglacial history and how this impacted the human development that happened in the early centuries of European settlers in the US. So that was the Pleistocene epoch. Now, since that time, we've been experiencing sea level rise. And there's actually two types of sea level rise. The first one is more familiar to everyone. So that's where the ocean is rising relative to where you are on the land. A lesser known form of sea level rise is isostatic sea level rise. That's where the land is actually sinking relative to the ocean. And so New Jersey has the unlucky fate of being having both of these things. So when those glaciers melted after the Pleistocene epoch, this has caused a geologic rebound, which has basically left New Jersey sinking on our side of the seesaw because that mass of ice is no longer there. So New Jersey has been sinking ever since that time, contributing to more sea level rise. And now in our current era, we call it the Holocene, which contains all of human history and has had a relatively stable climate. But it has been proposed to be called the Anthropocene instead, which highlights the outsized impact of human activity on the environment. So as we've seen through the last series of slides, our planet has been on a temperature roller coaster that has its ups and downs. So why is the current warming any different? The difference is the fossil fuels. So essentially, we've been digging back into our geological history to take that carbon that had been buried under the earth, and we are burning it as fossil fuels. And so this has fueled this great increase in temperatures that we've seen over the past few decades. And so this global warming rate is really fast in comparison to historical measurements. And this figure here is really significant. So remember that last extinction event that we talked about, where they had 5,000 years over which the temperature of the globe increased by 5 degrees Celsius. So that's highlighted in yellow here. And then you compare that to the current trajectory that we have right now. That's the red line. In much less time, we've been going up at a very fast pace, and it's 10 times faster than that last known extinction event that was caused by global warming. So this is all happening because of the greenhouse effects. So as we've been putting that carbon dioxide back into the atmosphere is designed so that it is actually capturing heat on Earth. So that's made it habitable for humans. So that when sunlight enters the atmosphere, it is only a portion of it goes back to the sun, back into space, while the rest is retained here on Earth. But we've been supercharging this function of the atmosphere by adding more carbon dioxide and methane and other greenhouse gases in smaller amounts that are increasing the effectiveness with which heat is withheld. So as we are trapping more heat here, that is gradually warming our planet. Another recommendation for something that you can check out after this talk. I love the way that Catherine Hayhoe describes all these different aspects of climate change. She uses these cute little illustrations and breaks it down really well for the average person. So because of all these influences of the climate, the ocean is exerting increasing influence on South Jersey and is encroaching on the Pinelands. So one basic physical thing that's causing this is that when molecules are cold, they're more compact and they're closer together, but as they warm, they are expanding and becoming larger. So that is one of the reasons that the ocean is there's just more of it now. In addition to the glaciers and ice sheets melting, that is contributing more water that was previously locked up on land. So New Jersey is projected to experience significant sea level rise by the end of the century, with projections ranging from 2.5 to 5.1 feet by the year 2100. It says other consequences for our state, such as ocean acidification. So this excess carbon dioxide in the air is getting absorbed by the ocean, which lowers the pH levels, making it more acidic. And these acidic waters disrupt marine ecosystems, cause coral bleaching, and weaken aquatic biodiversity. And this is significant for a state like New Jersey, where we have big business in harvesting Eastern oysters, hard clams, and blue crabs, all of which are some of the animals that are impacted by the ocean acidification. And it can be particularly strong with these shell-bearing organisms because it requires much more energy for them to keep up, maintain their shells in the presence of ocean acidification. So the bottom line of this whole geological history that I just presented is that the climate has always been changing and humans have accelerated the rate of change. This rate of change matters because wildlife needs time to adapt. During that last extinction event, animals had 5,000 years to adapt, and it still wasn't enough time. There was still a large extinction event. And human activity and development has been built for current-ish climate conditions. I say ish because it's more like what the climate has been for the last 100 years, not really built for the current climate, nor what we know is going to come in the future. And this human development has also constrained the ability of animals to adapt. So usually you would have, as the ocean coastline was moving over New Jersey, the wetlands were able to recede, animals were able to recede with it. But now the pathways that wildlife would have taken to be able to adapt to a new place, someone's house is in the way. There's a road in the way. They just can't get there, and the land is not available. So we're going to take a break for questions. And my colleague Jennifer might be jumping in here. Do we have any questions that we want to address right now?
Yeah, you can put them in the Q&A, or if you want to try to raise your hand, I can unmute you, whichever is easier.
Happy to see a lot of familiar names like Jason Vale. I saw Adam Nolan on here too. Yeah. And Ruth Darlington. Okay, if no questions, then we can move on to Jen's section.
All righty. Heidi, thank you so much for having me. This is a lovely talk, and she's doing an amazing job of explaining the mechanisms.
Oh, actually, I think we're.
Oh, do you have a question?
I think it'll actually be the next break for questions. That's when you'll take over.
Oh, okay. Then I'm
Sorry
going
about
to
that.
and I'll see you in a little bit.
Yeah. Sorry, thank you. Okay, back to me again. So the New Jersey Pine Barrens were adapted to the climate of the last 20,000 years. How is climate change affecting this now? So if you want to know about how climate change is impacting different levels, like the globe, our country, New Jersey, there's many different nice reports that you can reference, really dense with a lot of information, but they've usually created some nice digests, webinars, things to help explain things. So for the global scale, you want to check out the IPCC. And then their last report was a few years ago. And then on the national level, we have the United States National Climate Assessment. The last one was released in 2023. The next one is, well, it was scheduled to be released in 2028. I don't think it's technically canceled, but the Trump administration has cut all of the funding for it and dismissed all the scientists. So you don't need to be an expert in project management to know that if you don't have any money and no people that are working on something, then it's probably not going to get done. And then here in New Jersey, every year, we have a fantastic team that puts out the state level assessment of the climate status of New Jersey. So the last one was released about this time last year. So maybe any day now we'll be expecting the one for this year. So they go over the progression of climate change throughout all of the history that we've studied in New Jersey, and they incorporate the latest science. But then they'll also take a more granular look at just what was the last year like. So I'm sure this next report is going to be pretty crazy. So from this report, we can see that the average temperature in 2100 for New Jersey will be 3.7 to 6.2 degrees Fahrenheit hotter than it was over the previous decade. The sea level will be about 4 to 6.3 feet above the mean sea level from that time. And the annual rainfall will increase 3 to 13%. It's not a huge one for that particular factor, but the extreme rainfall is the thing to really pay attention to here. That's expected to increase by 5 to 15%. And they're generally referring with the extreme precipitation events to that top 1%, what was typically referred to as the 100-year storm. But as climate change has been changing that, it becomes kind of silly to say that every few years we're having the 100-year storm. We really need to move our benchmark of what we expect to be happening in a given year. And then the frequency of wildfires will increase, resulting in poor air quality. But if we refer back to our basic Pinelands, Pine Barrens characteristics, we know that fire is a big part of what is forming the ecology of South Jersey. And the sandy soil that we described in the geologic history, that has really been undergirding what makes the Pinelands so unique. It affects the way that water moves throughout the Pinelands. It impacts the way that we have these frequent fires, and it impacts the way that plants have adapted to what we call the sugar sand. So the Pinelands has high drainage and low nutrients, very unique growing conditions, very difficult. That's why these were called pine barrens, because European settlers weren't able to grow the things that they wanted to. And so plants have adapted to that. And it's created this unconfined aquifer, which we described previously as the Kirkwood-Cohansey aquifer. So you can see in this image here that the water table is just below the surface. It's continuous throughout the whole thing. And so when you see a stream, that's really just the water table that's peaking above the surface. And so any changes in this water table can have really profound impacts for whatever's living at the surface. And it also makes us more susceptible to subsidence. So as water is being pumped out of the aquifer at an unsustainable rate, the grains of sand are compacting and readjusting to having less water there. And so it's really hard to take the cat, once the cat's out of the bag, you're trying to put the toothpaste back in the tube. That has contributed to why we are sinking here in South Jersey, in addition to that geological seesaw that I described previously. And then as water is being pumped out and the sea level is rising, this is also leading to saltwater intrusion, where saltwater is reaching the wells that we've dug that were assuming previous hydrologic conditions. And so this is considered forced towns like Cape May City to consider more desalination, where they're taking this salty water and needing to expend a lot of energy to be able to remove it and have drinkable water. So these precipitation changes that are being driven by climate, these are causing some extremes. So in South Jersey and the rest of the US overall, you'll have areas that are experiencing more extremes of both droughts and flooding. So rather than the moderate conditions that we've been used to, you'll have it swing wildly between these two extremes. So New Jersey has seen a 7% rise in total annual precipitation since the early 1900s. And this has led to a significant increase in those extreme 24-hour rainfall events. Again, the 100-year storm that is happening more frequently. And then that Rutgers report, State of the Climate, it stated that extreme rainfall is predicted to increase by 5 to 15% by the century's end. And so we saw this roller coaster in effect last year in 2024. So we started off with that wettest spring on record, and then quickly went into the unprecedented droughts that happened in the fall. So it started with that drought watch that was declared on October 17th, which was escalated to a drought warning in mid-November. And then that particular drought ended the other month, back in May, when we had the 5th wettest May on record statewide. But if it is not, when we're not experiencing these unprecedented rains, we also are experiencing droughts, and this is contributing to the changes in fire regime that we have in the Pinelands. So the Pinelands are dependent on frequent burns. These help to maintain the unique Pinelands flora. But since 1900, the average temperatures in New Jersey have risen about 3.5 degrees Fahrenheit, and this has lengthened droughts and increased the fire-prone conditions. So these sporadic rains and the higher temperatures, they change the frequency and the intensity of the fires that we experience. And so what used to be the official start of fire season, March 15th, it is still the official start. You're really seeing fires happening in February, sometimes January. And so this quote from Greg McLaughlin, who is with the New Jersey Forest Fire Service, he said, "We're seeing this peak fire season that was confined previously to about 2 to 3 months. It is now a 4 to 5 month period." And so the fire season for 2025, we saw the climate forces interacting. That drought that was lingering since last year, it caused DEP to have to postpone many of the prescribed burns that they had planned. So they were only able to perform 22% of what they had planned. And instead, we had 214 fires by early March. So before fire season has even officially started, you've got 214 fires. And those have burned 514 acres. And I believe during that period of time last year, it was about 21 acres. So you've got about 500 acres more that were burned early in the year. And this contributed to the largest Pinelands fire that we've seen in 2 decades. So the Jones Road fire is scorched over 15,000 acres, displaced about 5,000 residents, disrupted power to 25,000 homes, and took 2 weeks of intense firefighting to be able to bring it under control. So the Pinelands are adapted to fire, especially our pitch pines that are the emblem and what the Pinelands are named after. They're able to resprout from their trunks, this epicormic sprouting after a fire, and their trunks are especially resistant to fire. And then their pine cones are designed to open after they've been burned, so that when the field has been cleared, when the neighborhood has been burned down, they can reestablish and they have more room to be able to reproduce because everything around them has been cleared out. So Pinelands trees evolved with these frequent but cooler surface fires. They are not the mega fires that we know of today. So while pitch pines can survive the low to moderate intensity fires, high intensity crown fires are far more destructive. And those are what are increasingly happen as a result of climate change. And that's what we need forest management to try to reduce. So some of these habitats, like the pine plains or scrub oak forests, they can recover from a fire pretty well if it's occurring every 15 to 25 years. But climate change is causing these intervals to shorten as fire occurs more frequently. Okay, here's our second break for questions, and Jen, this is when you're gonna jump in.
Yeah, so same thing. If anyone has a question, you can put it in the Q&A, or if you want to do the little raise your hand button, I can click on you to unmute you.
Yeah, as for availability of slides, we've been posting the recordings. Are we recording right now? Hopefully. On
We
YouTube
are.
within a few weeks afterwards. And then we'll do a follow-up email that has links to all of the things that I've recommended that you check out along the way.
And then Heidi, can you see the questions in the Q&A?
Mhm.
Okay.
Mm. Okay, so Adam asks, going back a bit, how does more carbon dioxide and methane trap heat and increase the greenhouse effect? So it's just the physical properties of these things. So like if you look at planets that don't have an atmosphere, some of the other planets in our solar system, they don't have this blanket of the carbon dioxide and methane, and we can see that they are much colder, especially as they're further from the sun, because even the little bit of energy that they do receive, it's just going back into space. So that is this atmosphere that includes the carbon dioxide and methane is part of what is making our Earth habitable, but it's also what's contributing to this effect. So essentially, we're just adding more layers to this blanket that's around the world with the carbon dioxide and methane. If I can, let me know if you have if you'd like some more on that question, or if Jen, if you have anything to add there. And then Jason asks, natural forces aside, in your opinion, how effective are the current policies and regulations in preventing over extraction of water from the aquifer from our communities? We were just a few of us PPA staff were on a call this morning with people at DEP that look through the water allocation permits and requests. And one large hole in this whole schema is that farms are basically able to do whatever they want. They do notify DEP of what they intend to withdraw, but because of the Right to Farm Act, there's no really restriction on what they can do. It would be great if there were things that were encouraging more best management practices, like more responsible irrigation. But then there's also just overdevelopment, which we are, getting a hold on. In the next webinar, when we're going to talk about mitigation and adaptation, we'll make sure to touch more on that topic. After the retreat of the glacier, wouldn't the land rebound and rise rather than sink? That's a good question. So for places where you had the glacier on top of you, they are rebounding upwards. So probably, but then since South Jersey did not have the glacier on it, during that time, I guess I'll just use my hands here. So you've got your glacier, that's my fist here. So what was previously a flat continent, the places where the glacier is, those are being bowed downwards, but then this edge of my hand, that's being bowed upwards. So New Jersey was lifted by the glacier when it existed. And then as that glacier melted away, these lands that were under the glacier in the palm of my hand, those are rising. But then South Jersey on the other end of the seesaw was sinking. And has the recent increase in carbon dioxide been reflected in observable increased plant growth in the pinelands? It's a very interesting question. I don't know if I know the answer to that.
I'll jump in.
Mhm.
This isn't as good an answer as I would like to give, but I definitely know that there are measurements of the eddy covariance in the CO2 flux, and then looking at basic respiration of the forest tied to some of this data. And I'm not sure who's asking this question, but and I apologize, I don't have a better answer right now, but I know which papers to look in to find a better answer for that. And it wouldn't necessarily be so much, because the question is an outstanding question, very logical question. It may not necessarily be so much as a direct measurement of plant growth, but what we might be seeing is changes in the respiration given off by, say, a whole forest. I don't know if we've been taking measurements long enough to go back far enough to see real differences tied to correlating very strongly with either temperature or to your point, CO2 levels. But I know where I can look for some papers to get a little bit more insight into that. So and I apologize for not knowing I can't see the chat, but feel free to zap me a little email or we can communicate somehow, and I can dig up some papers on that. And give you a synopsis. I won't make you read all the papers unless you want.
And
So this is a great.
sorry, real quick. I think Kate had her hand raised, so I unmuted you. You would just have to unmute yourself, Kate, if you do want to still ask a question. We'll give you a minute or so, and then if not, you guys can continue on.
Me.
If not, I'd like to take the opportunity to more formally introduce Jen, who has popped in and out. So she has been our science director for, oh wait, not since 2025.
Yeah,
it was last
almost a
year.
Mhm.
So I gotta correct that. She's been our science director since last year, 2024. So take it away, Jen.
All right. And again, Heidi, thank you so much for having me. This is an important conversation. What Heidi asked me to do today is just to highlight a few of the species that we directly care about very much here in South Jersey, and even an ecosystem that is so important for supporting the species we care about in South Jersey, the Atlantic white cedar system. And the first one I want to talk about is the Pine Barrens tree frog. As you all know, the Pine Barrens tree frog is this very special, beautiful frog that we love, that we have here in South Jersey, absolutely threatened. And it's threatened because it occupies a very distinct and very specialized niche. It is comfortable in acidic water. It's comfortable in water with a relatively low pH. And then it breeds in these ephemeral pools that don't last very long, so that they're somewhat sheltered from predators in that environment. So it occupies this very specialized niche, making its distribution fairly patchy. It doesn't only live in New Jersey. So in the many conversations Heidi and I got to have as she was putting together this whole talk and this whole lesson here that we're getting today, we came across a paper, and we found a paper, there it is, by Warwick et al., a group of scholars that were using genetic analysis and using modeling to characterize the radiation of the Pine Barrens tree frog across the U.S., the eastern U.S., in the last, 500,000, 100,000 years, couple 100,000 years. And they showed that you have genetically distinct populations that had radiated apart from each other because it is from such a unique and distinct ecosystem. Its habitats are so unique and distinct that it can only live in certain areas, thus making it isolated. So we can't logically have interbreeding, between a Carolina population and a New Jersey population, or the population of the Panhandle of Florida. So they showed that over the course of couple 100,000 years, you had this evolutionary radiation of Pine Barrens tree frogs directly tied to the climate changes that were occurring at that time. Some of those climate changes that were very naturally occurring that Heidi talked about earlier today. So you have this natural occurrence of the environment and the climate selecting for distinct populations. And so what you then get is the outcome of that is this isolated populations, and part of what has led to them being quite vulnerable today. And so what happened over the course of hundreds of thousands of years before that allowed to the differentiation of this species has now been occurring over the last 100 years. So I'm using this as an example to really emphasize the complexity of what we're dealing with, is that so many of the changes we see, past changes in climate over hundreds of thousands, millions or more years, and the species have adapted to that and evolved to that and adapted to their habitats to that over 150,000 years. Well, now, unfortunately, what we're doing is changing the climate over the period of 100 years or 200 years. And so that puts extreme pressure on vulnerable species, especially those that are adapted to very distinct niche, like the pine barrens tree frog. So the pine barrens tree frog it's adapted to a very sensitive habitat. It's adapted to these ephemeral pools. It tolerates low pH. A lot of organisms don't tolerate that low pH. And so, and again, tying back to another thing we're about to talk about, it prefers to breed in the cedar swamps, the Atlantic white cedar swamps.
Mm.
And so now, as those habitats are going to be changing with the changing climate, they're just going to be that much more vulnerable. The droughts, the fires, etc. So if we move on to the next organism, exactly, this perfect segue over to the fate of our gorgeous, beautiful cedar swamps. They're just so iconic of South Jersey, so unique, so distinct, and ecologically so important for supporting our rare species. They themselves are rare, but the habitat itself is also extremely rare, and it supports, the pitcher plants, a lot of those really interesting carnivorous plants that we all get so excited about. The reason we have the cedar swamps here is that very special hydrology. We have this very special hydrology where Heidi explained it beautifully, where the aquifer is just so close to the top. And so you have this dynamic, partially dry, partially wet, kind of flooding up and flooding down environment that the white cedar is adapted to. It's adapted to that lower pH, but then also it is adapted to having its feet sometimes wet. It
I love
doesn't
that
like,
phrase.
sorry?
I
Oh,
love how you
sometimes
describe
wet?
them. They like their
Yeah,
feet wet.
yeah. Yeah, I know. I'm a soil ecologist, so that's why I think about it. Yeah, they do. They want their feet sometimes wet. And it's created a hummocking in those habitats. And if any of you have out there ever walked amongst them, they're absolutely beautiful. And these little islands within these cedar swamps support so many different species, including our tree frogs, but also including some of those carnivorous plants and plenty of other things that we haven't even looked at yet. So as the aquifer draws down, that dries down. As we have droughts, that dries down. And then what's happening with the drying, so we have two problems hitting the cedar swamps. What's happening with the drying when there's drought is, one, that allows for fire to come in, and this is not a fire tolerant species. It allows for fire to come in. It also allows for that soil to dry out. And that soil dries out, it's not really the happy place for that plant. But then also, as we care about the feedbacks to climate change, it also allows for carbon to be released. Wet soils tend to hold their organic carbon better than dry soils for a lot of reasons that I'm happy to discuss when we have more time. So then you have the problem of drying on these habitats. But then on the other side of it, you have the problem of when they're too wet. When they're too wet, when there's flooding events, or when the hydrology changes associated with road building, and then, or you have, in this case, maybe even saltwater encroachment coming into these systems, where an environment that once used to be able to go up and down in its hydrology is now permanently flooded. You end up with the ghost forests because the Atlantic white cedar doesn't tolerate that. Or beavers. Absolutely. Beavers can do that too.
And I apologize, this part got
Mhm.
cut off, but
Mhm.
the number one here with the 2,100 to 3,000 acres
Oh,
of ghost forest that we find along our coast,
yeah.
it got cut off here. That is Bernard Isaacson's analysis that he did.
Oh, yes. Thank you. Absolute credit. For sure. Credit. All right. So, and then, oh yeah, I said this is a minute ago, and then, but this is a great time to reiterate this. Habitats like the Atlantic white cedar swamps, are distinctly valuable for storing carbon. So not only they are valuable in the sense of storing carbon because you have this, massive forest of trees and all the carbon that's held within that, but so much carbon is stored in soils Soils are incredibly important for this. So all the organic matter that's in the roots and the feet of those plants and all the organisms that live down there, when an environment is floody, kind of gets trapped. It kind of stays there safely, and it stays there safely below ground. And this particular plant community is adapted to that. And so it stores carbon and protects it from moving into the atmosphere. When these swamps dry out, then that carbon can be released, especially when that soil ends up being disturbed because animals come through or fire comes through, then that soil will get released. So it's no longer serving as not only a habitat for so many beautiful diverse species, but also a carbon sink. All right, and then now let's talk about the northern pine snake. This beautiful, lovely snake that also is adapted to a very distinct niche. It's adapted to the sandy soils. It wants to burrow. It wants to, build its nests in sandy ecosystems. And so when you have alterations to the climate regime that are either leading to changes in temperature that affect when the snakes emerge and mate and don't emerge and nest, it's altering their reproductive habits. But then also fires coming through are going to affect that, and floods are going to affect that because they're a burrowing organism. So if you have a flood come through, then their burrow could easily get flooded out. So this is another one of our just distinct and iconically pine barrens organisms that is really vulnerable in a changing climate, and particularly here in South Jersey. And then the ORV issue, of course, that's indirectly related to climate, but
Yeah. So I included
definitely.
the pine snakes here, from what we heard from Joanna Berg's research,
Yeah.
where she was saying that the variability that has been increasing, we don't really know so well when they're coming out of hibernation and when they're going in. It's harder to predict, but we the way that we've been enforcing, trying to make sure that people aren't poaching these snakes or that they're not running over the snakes with ORVs. We send enforcement officers out there during times that we know that they're going to be active, when the snakes are going to be active. But because their timing is now just all over the place, it makes it very hard to plan when these enforcement things are going to be happening.
Yeah, kind of back to someone that is asking this, how are we going to manage this?
Mhm.
Even when we want to do the right thing, it's going to become hard. Oh, and they're going to be so vulnerable to fire. So, to some degrees, naturally occurring pine barrens fires open up the habitat and create the habitat that they thrive in. But a wildfire, when we can't do our prescribed burns on a regular basis because it's too dry, then we are vulnerable to large catastrophic fires because the fuel load is high, et cetera. So it becomes a kind of a distressing feedback loop. And other species as well. We had a wonderful population of eastern spadefoot toads emerging at our Rancocas Creek farm this year. That was so much fun for everybody, and hopefully they were very productive. That said, back to management, we did water their puddles because they were drying down so fast, and we all really wanted to see them survive. So we managed that situation. Not all situations can and should be managed. And in that case, we did. And hopefully they'll survive. But this is a species that in particular has again, a very distinct niche with respect to climate. It needs it to rain. It needs it to build a bunch of, big ponds and puddles. So it can quickly emerge, quickly reproduce, quickly make the babies, and then go back below ground. But the timing of that is critical. And if it's too dry and the puddles don't last long enough, then it won't work. So that's very important. And obviously swamp pink too is another organism that's very dependent on the hydrology and the moisture regimes and the hydrology that we have so distinctly here. So secondary problems that are coming from this, coming from alterations in temperature regimes, are the migration of insects, the movement, the steady northern movement of a lot of species that weren't otherwise really thought of in our area are now, even if not exotically invasive, say from Asia or something, even those that are local are starting to just spend more time more north more often because it's warmer. I think that's probably why we're seeing way more ticks this year than we have. I think there's going to be natural boom bust population cycles with any organism. But I think that, just steady increase in earlier summers getting warmer earlier, it's staying warmer longer, winters are getting shorter. Even though we had some really nice cold days this winter, it's only a few of them, and that may not be enough to keep these insects under control. And that's going to be a problem for human health and a lot of organisms as well. So thank you for having me. I'm going to blink back out and
Yeah,
I'm going to
thanks
let
so
Honey
much.
take back over. So it's nice to be here. I'm going to keep listening. So
Yeah.
thanks for
Thanks so
having
much
me.
for jumping in, Jen.
Mhm.
Yeah. So since our organization was established in 1989, PPA has been the leading voice for protecting the natural and cultural resources of the New Jersey Pinelands. So because of this, we've been working to raise awareness about climate change and its ongoing and anticipated effects in the Pinelands. Many of the stories that we just shared with you about the effects of climate change in the Pinelands are based on disjunct studies of these species. Unfortunately, we didn't have a lot of like nice graphs that we could show you because no one's been making them, at least not in a very comprehensive way for our region. And so comprehensive studies have yet to be conducted. So for this reason, recognizing the need to fill the significant research gap, PPA has established the Pinelands Research Institute just the other month, and we're bringing science and people together to build knowledge and understanding that promotes sustainable and healthy ecosystems. This science-based field station in the Pine Barrens of southern New Jersey will be for the scientists, educators, naturalists, and the public to generate knowledge and understanding of this ecosystem and the policies of the Pinelands Regional Land Use Planning System. So we're hoping that with the research that is catalyzed by our research institute, that if we give this webinar a few years from now, that we'll have really rich data to be able to present to you and just create like a whole network of scientists who are looking at this from every age, from every angle, but who are being convened by this Pinelands Research Institute. One exciting collaboration that we have going on this summer is we're working with a team from NASA through their Develop program. So we've got a team of people that are using remote sensing to characterize our New Jersey Pinelands water resources. So that is some exciting research that is going on right now. And they'll be mapping the wetland extent to see how this view has changed from space over the decades. So later this year, hopefully we'll have some really cool products to be able to show you all about how both climate change and the way that we've been withdrawing water from the aquifer, how this has changed the region that is occupied by wetlands in the Pinelands. So although we say that more research is needed, we need more research to be able to understand the system. It is not an excuse to be inactive. So two things are true at the same time. We need to learn more about climate change, and we need to take urgent action to mitigate and adapt to climate change. If we try to hold still and just study the ecosystem as it is right now and say that we can't take action until we understand every single thing at the moment, that's really folly, because trying to study a changing climate is like trying to hit a moving target. By the time that you think you fully understand the system, it has already changed. And we have ample evidence that the climate change is happening, that it is man-made, and that we have the tools to address this today. And so it's become more rare these days that you find people who are outright denying that the climate is changing, but you have an increasing group of people who are delaying climate action. So climate denial has become the new climate delay. So you have excuses that are bandied about. What aboutism? People might ask, well, what about China? What about these other countries that are emitting more than us? Although on a per capita basis, the United States is the worst. There's technological optimism that motivates people to say that tech solutions that will fix all of this are only a few years away. So let's not, let's not move forward with what we have on the table because there's going to be something better later. And this contributes to policy and technology perfectionism, where you're letting the perfect be the enemy of the good. When we have great technologies that we know can produce clean energy like solar and wind, but people are going to wait for nuclear fission. We need all of these things really, and we need them as soon as possible. So I wanted to highlight for everyone this figure from the latest IPCC report. It shows the extent to which current and future generations will experience a hotter and different world, and how that depends on the choices that we make now. So on this figure, we can see as we move from left to right, as we're progressing forward in time, moving forward from 1900 to the year 2020, how the global temperatures are becoming much warmer. And we are at a fork in the road, multiple forks in the road, where we can see how the emissions will change based on whether we have very low or very high emissions. And these are based on whether we achieve net zero in our carbon emissions. So the very low scenario requires that we are net zero by 2050, low 2070. Intermediate, we need to do it by 2100-ish. But then the high and very high trajectories, they show if we just stay on our current trajectory in which we are increasing our rate of fossil fuel use. And then the very high one shows if we even accelerate, if we're going even faster, if something very disruptive like AI, how we see that that is really ramped up energy needs in only a short matter of a few years. So if that were to continue unchecked, we would probably see something like the accelerated emission scenario. But the thing that I thought was really profound about this figure is that it shows what it's like for people who are living through this. So for argument's sake, my dad, he just turned 70 recently. So when he was born, the climate looked very different than it does today. And people of his generation are making decisions that impact the rest of us, how the rest of us will be living long beyond when they are with us. And so I'm a little younger than this, but for argument's sake, born in 1980, the current climate that I'm experiencing now will become much hotter by the time that I'm 70, regardless of what decisions we make. And then my daughter, who was born in 2020, she will experience the worst of all these things, regardless of the decisions that we make. There will be climate change, but we have the moment right now to be able to change these trajectories and make it less bad. So just a sneak peek of what we'll be touching on in our next webinar. We're going to talk about mitigation. So these are the ways that we reduce that trajectory. How do we make climate change not so bad? And then we'll also be covering all the different adaptation methods, and we'll be tailoring this to our Pinelands ecosystem. So both what does policy in New Jersey look like, but what are things that we can do in South Jersey to help the Pinelands and the people of the Pinelands adapt to climate change. And so the take-home messages from today's presentation, hopefully you'll remember that layer cake and all of the things that happened in New Jersey's climate history, but how all of that has been shaped by the climate and created the South Jersey and Pinelands of today. And then how climate change works, and then how the current rate at which we're experiencing climate change is unprecedented. And that we need more research. Get involved with what we're doing at the Research Institute. But even though more research is needed, we know enough that we can take changes. We can make those changes now. So to learn more about this, tune in for the second part of our webinar. That will be in August, taking a break month from that, when we'll focus on adaptation and mitigation. And we'll have a registration link for that in the follow-up email. And then July, it's going to be Plastic-Free July, and we're going to be taking a break from our 35th anniversary webinar series to talk about artificial turf and why we want to get it out of South Jersey and the rest of our state. So that's going to be on Wednesday, July 23rd at 12 p.m. on this same Microsoft Teams. But if you're feeling motivated by what you heard today and you want to get started right now, I highly recommend that you start composting in your backyard. That can cut the emissions from the food that you eat. Plant a rain garden. Talk with my colleague Steve Elliott about how you can get a rain garden and transform your lawn today to make a difference for the environment and the climate. Go solar, especially if these tax credits might be going away. We need to tell Congress that we want to keep the green energy tax credits. But you have at least a month or two to be able to still take action on this if you want to go solar. So thank you to all of you for tuning in, and also a big thank you to the photographers who give us their photos every year through our competition. So if you are a budding photographer and you or an amateur one, we've had some winners using their iPhone photos. Take photos throughout the year and send them to us for our photo exhibit next spring. And that's it. We can do another round of questions. But we are at the hour mark, so I won't be offended if everyone needs to log off.
Thank you so much, Heidi.
I'm not able to see the previous Q&A questions. I don't know if they were dismissed or it's not loading for me.
I just moved them out of the way so we didn't get all confused. But yeah, there's no other new ones right now that I see.
Okay.
There's people saying thank you in the chat.
Yes, there are definitely volunteer opportunities. Maybe we'll include some of those in our follow-up email. Jen, I'd be interested to know if there are any specific volunteer opportunities that you foresee with the Research Institute. And my apologies, I started the talk with 75% of my voice and now I've got like 50.
I know, and you're doing great. I'm so impressed. Absolutely. As we move into the fall, I would definitely love to be hosting field trips out there for sure. And I'm dreaming of organizing a BioBlitz. And yes, opportunities for sure. So that's another good thing to contact me. And the person with the question about plant growth in the Pinelands tied to potential levels of CO2, my brain is spinning. I can get you some better information on that.
And then for volunteer opportunities, Mike Pippin that we work with, I put his email in the chat. It's just mike@pinelandsalliance.org. He manages our volunteer opportunities, and you can go on our website and see the different things that we do, like cleanups or working in the garden, all of that. So you can also contact him. And I think that is everything. Thank you all. Thank you, Heidi and Jen. And yeah, we'll get the recording up and send you guys the link for the next one that you can sign up for. So thank you.
Thank you, Heidi, for leading us. That was so good.
Yeah, thank you.
I learned a lot.
See ya.
Have a good day, everyone. Stay cool.